Hey guys, don't know why my model keeps like not loading in. There we go, there I am. So weird. I heard you were giving out soup at the soup kitchen off 24th Street. Pretty cool. Don't know why you start going on long rants about some guy named Germa, but hey, at least you're doing a great thing for the homeless community. There's no 24th Street. That's a made-up number. I'm a math teacher, I know that. 24 is actually a myth. That's a myth they teach you to try and keep you from learning about the real numbers. Hey everybody, how's it going? Let's do jazz. Ghibli jazz. We're not doing physics, we're doing something, but I forgot the name of this section. I think it might be gradients. It's either gradients or directional derivatives, but to do directional derivatives you need gradients, so I can call my stream gradients. Multi-variable. Cool. Okay, let's see. I don't really know what I need to do, but we're gonna find that out together. We're gonna go on a beautiful journey of math. Okay, that's not it. Get there. Hope you guys are doing well. It's been a little while. My schedule's been like so weird because like I don't have. I wish I had like either Thursday or Friday a little bit more free because I can't really stream Thursdays or Fridays, so my schedule's just whack. I just gotta stream Saturdays. Okay, can I explain? Oh, can I explain the inverse of a matrix? I think I actually can. Do I remember? This is a good question. I do actually have my... You know what? That might be worth it. As I say, I do have my old linear notes. Oh, my desktop audio, 1 second. It's glitchy. We good? This one maybe? Oops. Yeah. Okay, let me grab my notes, because I remember a little bit, but I don't remember how to do it exactly. I brought this just because I knew I was gonna be doing linear analysis at some point, and I was like, I might as well bring my old notes. Crazy vector calculus note. Oh yeah, I forgot this insanity is up right now. There's like a little bit more I have to do of this section, but we're not gonna do this. We're gonna be doing... Dude. Okay. You said this is crazy vector calculus? It's actually not that crazy. It just sucks. Bro, my professor should have given us 2 of these problems. He gave us like 13. It's just so much writing. Like, it's stupid. Who's Germa? Germa is a streamer. He's a streamer guy. He's a funny man. Okay, let's see. Where is inverse of a matrix? Wait till I get to triple integrals. I'm excited. I like multivariable. Actually, my first midterm like coming up soon-ish. These are all dimensions and ranges. Way later. Let's see. Characteristic polynomial eigenvalues, that's after determinants? Is that after the inverse or before the inverse? That's gotta be before, right? Orthonormal, transformations, symmetric. I have a lot of... Why did I go? Oh, Umbra's lying. Umbra's doing a bit that's not true. That didn't happen. I hate multivariable, especially space curves? Aw. I think it's kind of cool. I think it's not that different than just regular calculus. I thought it was going to be like a lot different. Where are my inverse? Okay, there's no way. We're not even... I wasn't even... Okay, it's going to take me a sec. Sorry about this. That's what happens when you have notes and you don't have any rhyme or reason to them. The limit in multivariables? Okay, yeah, that is one thing that I don't really... Okay, find the inverse. So, okay, there are two ways you can do it. One way that I know how to do it that might be the easiest for you is, like, let's say you have a 3x3. Okay. Let's just put some values in here. Is this... Wait, is this marker the same size? No, it's not. Let me... Okay. One way that's pretty, like, pretty chill, I think, at least in terms of work, is let's say you have a 3x3 of A, B, C, D, E, F, G, H, I. And you want to find the inverse of this, right? One thing you can do is you can adjoin, which is adjoin, an identity matrix to the right of this matrix. So that means we just write this, right? And then, if you row reduce it so that this part gets down to something 1, 0, 0, 0, 1, 0, 0, 0, 1, the numbers over here are going to be your identity. So it's not really too bad. So just anything you do over on the left, you'll do over on the right. So yeah, okay, row reduction isn't easy. You're right. But row reduction is... It's not a lot of hard steps. It's just a lot of steps. One thing that how do I find this interesting? Because I love math. It's so sexy. Look at these little numbers. One thing that I suggest with row reduction that I always do, so let's say I wanted to divide this row by 2, this top row, and then also divide, like, subtract these 2 rows. So we'll say that. So one thing I always write, like between my matrices, is I will do little marginal notes, and then I'll rewrite it out. So that way, if I make a mistake, then I can, like, go back and check my work pretty easily. Linear algebra is crazy. It can take up to 30 minutes to solve a question. Yeah, I mean, I definitely got lucky. The person I had teaching me linear algebra was pretty nice. Like, he gave us like 3x3s, but he didn't really give us 4x4s a lot, which is when it can get really, really irritating. Lagrange multiplier is crazy. I actually just did that today. I like it. I think it's kind of cute. And zeta function, Lagrange is like, you just have to do this. And to be fair, I took I took linear analysis before I took multivariable. So, like, looking at this and then getting a system of equations is like, it's really so much nicer than having to deal with, like, doing partials of probably like a square root or something. But we actually are going to do some of that right now. Just full circle, baby. Let's see, we're getting there. I think it's chapter 4. Wait, oh, it is chapter 14. Cool. 14 point. What class number is the linear analysis? So the classes at my university are based off of what year people usually take them. So 100 levels first year, 200 levels second year, 300 level is. So my linear analysis is 2. So right now I'm in 241. So 4 is like, I think that denotes that it's specifically for STEM majors. And then linear analysis 1, ours is split into 2 parts, is 244, I believe. It's kind of a weird system. But yeah, normally we have like the first numbers based off of year, not necessarily difficulty. But yeah, 208 is... It's crazy that all the calculus classes are 100 level, but they're still not easy. Yeah, calc can be really tricky to wrap your head around. Oh, I don't have my... Wait, I do have that. I did... Okay, good. I was about to say, I didn't want to make sure that was... Okay. Okay, directional derivatives and gradient vectors. Cute stuff. How come calculus 1 is 152? I don't know. Course numbers are weird. Oh, it should be 200 level? Well, it might be depending on what year you're supposed to take it. So like, in my major, people are supposed to take Calc 1, Calc 1 like the first quarter of their first year. So it's a 1. So it's like 141, 142, 143 is Calc 1, 2, 3. And then 241 is Calc 4. And then maybe it's 242, but I think it's 244. That's linear analysis. It just depends on like what other... Most first quarter are taking college algebra or pre-calc. Yeah, but like I'm an engineering major, so we have to take... it's assumed that we took calculus in high school. Or at least pre-calc, I think. I don't remember exactly what the requirements are, but you can take like pre-calc your first quarter here, but like they kind of... You will be a little bit behind, I think, if you do that in the... I hate pre-calculus. Pre-calc is one of those things where it's kind of like Calc 3, where it can really be hit or miss, because my pre-calc, we did like a lot of kind of useful stuff, surprisingly, but it wasn't taught in the most useful way. Like we actually did like polar coordinates in calc, in pre-calc, in my pre-calc, but we just sort of did them at a very like not useful level. 15, 17, 20, 23. Series and sequences are really hard, mostly because I think the motivation for series and sequences is so hard. I'm so glad I took Calc 3 with a professor who was able to give a good motivation for it. Because if you don't realize why you're doing it, you're like, wow, this really sucks. And you're not wrong. Okay. So we have to find the directional derivative. Like, 87% is not bad. If you want to get into grad school, then, like, you know, that's a different case, but, like, dude, 87% is chilling. I mean, maybe that's just me. I never really... Well, okay, not never really, but I'm always the person to care about, like, if I learn the stuff more than what percentage grade I get. Because if I get a good grade but I don't learn anything, then... Yeah, directional derivative is the gradient times the unit vector. So, okay, I guess the way we have to do this is... Let me see if they give an example of this, because I don't know the way they want me to find u. Let's see. They probably have. This book is actually pretty good. I think this might be... This is like really similar to the books that I used for high school stuff. Except that, like, when I was learning differential calculus, we just didn't have a textbook. Like, we had to use Paul's notes because it was just like there was no textbooks that were... You just saddle point it. I know what a saddle point is, but I just need to see how they get u out of a point and a theta. Let's see. Oh, here we go, here we go. Oh, it's u is the unit vector given by the angle. Oh, okay. Did they write that and I'm just like really silly? So yeah, we just have cosine pi and, or whatever we have. What did I say? Pi over 3. Bro, pi over 3? Oh my god, we're gonna get a square root in there. That's nasty. That's nasty jazz. Okay. Okay, so I guess we can start by doing u. I don't know, it's like du, right? That's how you write it. So our u is gonna be x direction, which is cosine. So cos of pi over 3. Actually, I lied. I'm gonna call this like v, and then we'll we have to normalize it. So if we look at our little unit circle, pi over 3 is the bigger one here. So cosine is gonna be 1/2. And then we get root 2 over 2. So now to normalize this, we have to divide by the square root of this squared, so 1/4 plus 2 over 4. Component form, disgusting. Oh, you want me to write it like this? It makes more sense to write it like this because for this class, because we're not doing matrices, but then when you do anything with matrices, it makes way more sense to write it the other way. So this would be the square root of 3/4. I love... Okay, fine, it's fine, it's fine. So we want to divide by this, so that will be 4 over root 3. And you know what? I'll write it out like this for you. 1/2 root 2. I always wrote my unit vectors like this, where I like pulled out the thing. Oh yeah, it's good, but wait, I have to dot. Okay, whatever, I'll dot it. Okay, now we have to actually do the gradient vector. We're just chilling, we're good. So our gradient vector is going to be the partial derivative with respect to, here, I'll write this out for him. Partial derivative with respect to, this is f, with respect to u, or x, and then the partial derivative with respect to y, which is pretty neat. So this is going to be, with respect to x, that'll be y cubed minus 2x. And the other one will be 3y squared x. That's it. And then we want to... The concept of unit vector was not easy to understand. Yeah, so the way that I sort of understand it is, especially in linear algebra, right? A lot of it is about working with like the most basic things, right? So when you're working with vectors, sometimes to do operations on them, it's way easier if the magnitude of that vector is 1, rather than say like 75 over root 3 or something, which, you know, based off of a triangle, this is the square root of x squared plus y squared. So in the interest of making things easier for ourselves and being able to evaluate vectors in respect to each other, sometimes we need to take this norm and just like shrink it down. So the vector is like just scaled back or scaled up if the norm is less than 1, so that we can get like a consistency between vectors. Because sometimes we need to analyze, you know, like angles or see if there are other things. Like with a lot of matrices, you got to do that. You got to do that normalization. Also, it lets you check if stuff is scalar multiples of each other, which is really useful. Okay, so we'll do 8 minus 2. And this will be 3 times 4 times 1, so 12. So 612. And then we do gradient f dot u equals, well, we have 6, 12, so we'll do this. 6, 12. Dot, I guess I should do dot like that, probably 4 over root 3, 1/2. Nope. So this is going to equal 6 times 1/2. I'm going to just pull out the 4 root 3. So 3 plus, this is, sorry, my Discord notifications, I'll turn them off in a second. 6 root 3. 6 root 2. There we go. And that is our directional derivative at that point. So if we didn't specify a point, we would get an equation. But then we specified a point. So that's pretty neat. It's not too bad. It's like a little janky, but it's not really too janky. It's not as bad as all of the partials. I think partials in general can get really tedious because when you, like opening a Pandora's box, when you have to do like 3 partials, you'll probably have to do like 6 more, depending on the problem, obviously. But oh no, it's a 3-part question. Please don't tell me he gave me 9. Okay, no, he gave me 11. Cool. Hi, nice to see you're well. Oh, hey Luigi, how's it going, man? Vintage Luigi, that's a good name. I am doing well. I'm vibing out. So we need to find the gradient. We need to evaluate the gradient, and then find the math. Let's go. Yeah, math time. We're chilling. We're chilling. We're doing some chill math today. We love math. 100% Navi wanted to go into STEM. I can't tell if you were like 100% not me wanting to go into STEM, or like 100% I don't want to go into STEM. Okay, what's our f of x here? Sorry, f of x, y. We're getting fancy. We got 2 variables. Moving up in the world. Now I want to go into STEM, technology and engineering. Lol, am I in college? I am in college, yeah. Oh, are you asking the other person? Okay, this is just asking us longer steps of doing the thing we did up there, but maybe I can make it look a little nicer. Oh, and look at this, they gave us a U! How lovely! Wait, oh, I was reading the wrong thing. Okay, minus 15 13ths. Never mind, that's dyslexia. 5 13ths. 12 13ths. Dude, they did all that work for me. All right, they're asking for the gradient first, so that's easy. Big gaming moments, big gaming gamers. Okay, so that's 2x, right? So we do the derivative with respect to x. How's college treating you? It's treating me well. I have a lot of work, but it's fun, so I don't really mind. Look at that! Look at that! Look at that! I don't know. I just say df. Oh, okay, I can just do this. Fx, fy. Haha. The shortcuts. Oh, I'm a high school dropout. Finish off my GED later because I do want to go into materials science. Hell yeah. Dude, I know materials science people. Actually, I lied. The one materials science guy I knew, I think, transferred into Aero Astro. Oh, but material science is really cool, actually. Evaluate this at that. Okay, so at grad or undergrad? I am an undergrad. I just do a lot of math. Okay, so log of 1 is gonna be 0. Wait, what? Oh, I guess it is gonna be 0. Wait, uh-oh. Oh no, 1 and then 9. Bro, material science and transferring into aero science is, I don't know. It's like, I think it's interesting because it depends on what you want to do. A lot of people in engineering, like, you can kind of spin it depending on what program you're in here. Some, like, I'm mechanical and you can just do a lot of stuff. So some people, but like, there are some engineering majors that are just way more specific, and then people are like, oh shit, like I didn't realize, or even within, like, I guess even the more general ones, like some people will major in mechanical and they switch to electrical, or the other way around, or whatever. Okay, get this, and then we just dot them. These are so much nicer than the other ones. Oh my god. Okay. 0, 9 dotted with 5/13. Okay, well, the 5/13 is not very kind, but Mechie for the win. I love mechanical engineering. What's 9 times 12? I don't know that off the top of my head. Time to calculate it. 9 times 12. 108. That seemed kind of wrong, but did I do math? Did I math right? Let's see. 2x, L, and y, that's right. That's right. And then x is 3, so that's 6 times natural log of 108. Yeah, I think it's right. How do we do a natural log on this? Can I do a natural log on this? Have I ever tried to do a natural log on my phone's calculator? No, I guess I haven't. Oh, it's right there! Found it. Yeah, it's 0. Okay. I just wanted to make sure I was remembering my log rules. I'm smart. I'm smart. Oh my god. I did the dumbest thing. I was earlier today, there was a problem. It was a transverse wave, and it was like, the question was this. And oh, thank you. I love this song. And I, in my infinite wisdom, infinite wisdom, I was like, oh, sine of phi equals 0. It equals 1! It equals 1! 2 divided by 2 is not 0. Oh, that was so painful. That was my big calculation mistake for today. I was on a quiz. That was on a quiz. That was the L. That was the big L I took. Okay, f of xy equals ex sine y at 0 pi over 3. Okay, thank you for that. And then v... Oh, wait, do I have to normalize u? Oh, yeah. It was not great. Not my proudest moment. let me see if this works. 5 divided by 13. Square that. Plus 12 divided by 13 squared. Okay, it does equal 1. Let's see if our v is right. So 6 squared plus 8's, nope. Okay, so we gotta normalize this first. I was in EE at one point and forgot my scientific calculator. Tried to calculate square roots to 3 decimal places. Oh my god, that would be insane. Dude, I don't even know what I would do. Like, I think I would just have to be like, I'm sorry, I can't do this. I would just, oh my god, I'm just like thinking about that. That's like one of my worst nightmares. Okay, so we gotta unit vector this little shit. Okay, so square root 36 plus 64. That was the first quiz of the year. Didn't do well. That's the first quiz. It's the first quiz. You're fine. That's me 10. Look at that. Cute. So b equals -6. Oh, sorry. U. That's one of the things. I feel like I've done this rant before, but like. But one of the things they don't tell you about linear analysis or linear algebra, there are so many u's and so many v's, and you are going to write the wrong one at some point, and then your entire problem is going to be wrong. Because like my u's and v's, they're pretty similar normally, but you know, what can you do, right? Okay. If we do this with e to the x, this will just be e to the x sine y. Or sorry, we partial with respect to x. We partial with respect to y, we're going to get cos y e to the x. And then we do this at 0 pi over 3. Well, yeah. We'll just do a little equals. Okay, so if x is 0, it's going to be 1 times sine of pi over 3, which is going to be root 2 over 2. Yep. And then cosine, this will be 1/2. We need to do the z thing and put slash on all u's? Wait, that actually might be kind of based. Wait a second. Just like this? What would it be, like this? Whoa, that's kind of cool, actually. It's like, that's a v, but like u is like that? Maybe I should start doing that. Wait, that's kind of awesome. That's kind of dope. It's like, I'll never need to, and well, I mean, the only thing it could kind of look, no, alpha doesn't look like that. Like, what looks like nothing really looks like that. Oh. Wait, I might just start doing that. Yo. Okay, I'm stealing that. New trend. New trend. It was like I do all my 7s like with a slash through them. But like, we have to do exercises in lettering for engineering. Like, so if I wanted to write like damie, we have to write it like in a very particular way. But they make us write 1s like this and then 7s like this, and I'm like, that's just asking for trouble. Like putting a little thing on your 1 and then doing a 7 like that, and you're not doing like a slash through it. Also, I have to write 4s like this, and I haven't written 4s like this since I was like 3 years old. It's so hard. Oh my god, they also make you curl your 9s. Like you have to do like that. Like, and you have to do like that. Wait. It's really strange. It's kind of fun though. My handwriting is legible if I want it to be, but you know. Equals dot u equals, what are we doing? This is gonna be, okay, -6 root 2 over 20 plus 8 over 20. That's a 10. Cool, so 8 minus 6 root 2 over 20. Not too bad. Okay, I have so much more hope in this problem set than the other one. The other one was woof. All right. Ooh, we get 3 variables now. Big leagues here. X squared y plus... I only got 3 C's in K through 12. First was handwriting in grade school. Oh, that's so real. My handwriting got worse as the years went on. 1, 2, 3. Well, it's not that it got worse. I just, I journal, and I needed it to be, like, quick, so I stopped caring about, like, writing all of the, is this math an assignment? Yeah. It is, it's from a textbook that's online. If anyone is actually interested, I could drop a link, but it is, the title of the book is, Calculus, and the author is James Stewart. I usually do my assignments because a lot of the times they're like pretty good to explain stuff with. But like, I don't really have problem sets. This is just, it's not really like that. Okay. Gradient vector first, because my beloved. So 2xy plus nothing. Now if we do y, we're gonna get x squared plus 2yz. And then we'll do z, and we just get y squared. And we'll evaluate that. Stewart was a millionaire when he passed away? Yo, dude. Honestly, being a textbook author is crazy. Oh, my mic turned off for a second. My current professor is published. I don't remember if he's written just papers or books, but I think he's written books. But it's pretty cool. Okay, so 1 times 2 times 2, that's 4. Then we have 1 times 2 times 2 times 3, or 1 plus 2 times 2 times 3, so 4 times 3, so 12. And then we have 4. Okay, I don't know why that turned my canvas. Nope. Okay, so now for v, we want to make u equals the 1 over the square root of, I don't know. This would be the square root of 2 plus, nope, that's 4. 4 plus 4 plus 1. So that's 3. That's nice. And then this dotted with u equals, all right, so we've got 4 times 2 over 3. That's not a vector. 8 thirds plus 13 minus 13 thirds plus 8 thirds. It's gonna equal 1. No way. Is that actually 1? No, right? No. That's right, right? What does it mean if a dot product? Doesn't mean anything if a dot product is 1, right? If the dot product is 0, then they're orthogonal. That's weird. 1, huh? Wow. Okay. I mean, I guess I'm not complaining. Oh, I could simplify this a little bit. I'm realizing it could be 4 minus 3 over 10. Minus 3 root 2 over 10, but whatever. Okay. These are pretty chill. I think I have to do, yeah, one more. Whoa, we have a new function, h of SRT. Banshee schmancy. Ooh, it's a log of 3r plus, okay, it's RST. Dyslexia. 6s plus 9t. That's not a plus. Cool, and then the point is 1, 1, 1. And v is, oh, I'm just gonna write v in normal notation, 4, 12, 6. Cool. Yeah, we know the drill by now. I don't need to belabor it. Okay, this is a little annoying. I can pull out a 1 over 3r plus 6s plus 9t, because that'll be in all of them. And then we just say 3, 6, 9. I think. Oh my gosh, at 1, 1, 1? That's so funny. That'll be 1 over... what? 3 plus 6 plus 9. 18. Wow, these numbers are so... they're so clean. Why? This will be, oh god, 16 plus 144 plus 36. That doesn't seem like it'll be very clean, but I could be. 196? Is that a square root that I should know? 14? Yo! That's crazy. I mean, I could even take out... what do you think? Should I take out a 2? Should I be a little crazy? Should I take out a 2? Oh, should I take out a 3? I wonder how much the organic chemistry tutor YouTube guy gets for his videos. Dude, if you can... yeah, if you can get that kind of stuff, it's like, it's probably not a lot, but it's probably not a lot, you know? Like, no one really goes into it, I think, expecting to make money, but probably a pretty decent amount. I'll take out a 3, I'll be crazy. So that means this would be 1 over 6. That'd be 1, 2, 3 times... and for this one, 1 over 7 times 2, 3. What did I take out? I already forgot. 2, 3. No. Fuck. 2, 6. 2, 6, 3. Want to know a secret? Yeah. What's the secret? I hope you don't tell me something evil. Times 2 plus 12 plus 9. What is 2 plus 12 plus 2 plus 12 plus 9? 23. It's kind of a weird. What's the integral of secant squared? Tangent. Right? Yes. No, I don't want to cut the entire layer. Oh god. It's tangent, right? I think it's tangent. Am I sure? Secant squared? Yes. Yeah. Right? Oh no. You know, I'm gonna be honest, I was never that good at my trig derivatives. Well, it's not true. I just had to, like, practice them a lot before any of my exams. Wait a second. Tan derivative. Yes, it's secant squared. It's secant squared, yeah. Is that the secret? Is the secret that it is? Okay. Just doing more directional derivatives. I really don't feel like I need to do like this many of these, but you know. That's fine. 2, 1, 1. And then b equals 0, -3. So we're gonna have to normalize that. Oh, two-part explanation. I read a thing that the integral of 1 over x isn't ln x. Oh, I remember. Is it like an absolute value thing? Because I remember my professor talking about that at one point. Alright. I like finding the gradient vectors, that's the fun part. So that'd be y squared c cubed Then we have x, 2y. Look at this. It's like a little happy family. And then at 2, 1, 1. Okay, so that would be 1, 2. Nope, 2 times 2, 4. And then 3 times 2, 6. Huh. That's real awesome. Now you guys can feel the pain that I have to feel, which is doing these problems. They're not really that bad. They're just, it's worse because 1x is not continuous at the x. Yes. You know, I really should fix that. I don't... I need to install my headphone drivers. I'm so lazy, guys. I'm a scuffed cat boy, it's okay. It's really funny, though. I was saying that I think that's actually genuinely so cool. I do vaguely remember that. I think it was one of those things where my professor was like, or my teacher was like, here's a thing to think about, that you could think about. It's cool. You probably won't ever have to use it. And then I never had to use it. But it is neat. Okay, so that's 0, -12 over root 34 plus 5 times 6, which is 30? Yeah. So that's going to equal 20. 18. No clue if any of these are right. Whoa, wait a second. Okay, anyway, because secant squared x has infinitely many discontinuities, so each piece can have its own plus c. Do you have to do it as a series? Like a series of integrals? I didn't even think about that. Oh yeah, because secant squared is like... Wait, secant... What does secant squared look like? I actually don't know. Wait, let me look at that. Let me pull up a little graphing calculator, if you will. I haven't used Desmos in so long. I haven't needed it. It's so sad. Okay, secant squared x. Whoa! Oh, it's like crazy. There's a bunch of U-shapes, yeah. Looks like this. Like this. That's bonkers. How do you just do it with a series? Do you have to do a series? 23. Let's see. Oh my gosh, we're actually going through this like pretty quickly. I had 2 days. I had this on the schedule for like over 2 days. Okay, arctan. Oh no, 23. Okay, find the maximum rate of change at the given point and the direction in which it occurs. Okay. This is a fun, this is a thinker. Okay. So fxy equals sine xy. And our point is going to be 1, 0. So our u can be anything. But, okay. Our v can be anything, right? So we have x, we'll call it v1, v2. More linear algebra type beat. And then that means our u is going to be 1 over the square root of v1 squared plus v2 squared. v1, v2. Okay, so that's taken care of. The next thing is we need the gradient vector, which is going to be, in this case, it's going to be sine. No, we can pull out that. So cosine of xy times y x. And now we have to put the point in, 1, 0. So cosine of 0. So you're taking linear algebra next year, and how's physics? I'm taking linear algebra. No, I'm taking linear algebra next quarter. So that's in like 7 weeks after this week. And then physics is pretty good. We're doing waves. Yeah, I would normally take linear algebra next year, but I'm a little ahead of schedule, so. Unless I don't get in, which is a possibility, but I think I probably will. I don't think it's that hard to get into. Okay, cosine of 0 is 1 or -1? No, I lied. Cosine of 0 is just 1. Always good to be a bit ahead, yeah. No, absolutely. So 0, 1. I lied. No, I didn't lie. That's right. I do think it's good to be ahead. I'm very lucky that I got to be a year ahead. All throughout my, I guess, not primary schooling, but like my middle and high school, which is pretty cool. Which is very like nice. I don't think you need that, but it is kind of nice. Okay, so for this dot product, we're gonna get something to maximize, which we can do. This will give us, if we have 1, 0, that's going to give us just v2 over the square root of v1 squared plus v2 squared. And this represents all of the possible things, all the possible directional derivatives. Do you need to know coding for Mechie? Actually, I have to take a coding class, but I know how to code. I think I have to take a coding class that's like coding for engineers. I don't think it's like really that much coding. Like I had to do a little bit of Arduino, but like Mechie is more about designing parts and stuff than it is. Like there is a mechatronics concentration that you can take. Like you can do robots. What's my language of choice? Oh, it's so hard. I'm probably best at Java, but lately I do a lot of like web stuff. So that would be HTML and CSS, but also like some JavaScript. I really want to learn web server stuff. That's basically the one thing that's been stopping me from doing a lot of integrated projects. And it's so annoying to not be able to like know how to do data stuff with like online databases. So that's really my next goal. Do you want to use Node? Yeah, I mean, I have done some work with like, so I did work with like Postgres and GraphQL for someone else for a little bit a while ago. but I don't know how. I need to like know how to set it up more. Like, I also tried to use like Axios with like MongoDB, if you're familiar with any of those. But yeah, it's just rough to like have that first project where, because there're just so many choices of like what database to use, like then what like interfacer do you want to use with the database, or like what are you using to talk to the database, what are you using to like define. Kind of messed up. Okay. I recently got into React Native. You can use JavaScript to make iOS native apps. I did AppSign. I did Android stuff. I have a friend who was learning like Swift, and I heard about how it was to learn Swift, and then I said I'm not going to learn Swift. I also don't have an iPhone to like test on. But that's pretty awesome. Honestly, I feel bad for any developers who want to do iOS stuff, because it's just such a pain, in my opinion. I'm gonna come back to this one because I don't want to spend a bajillion years just staring at it. Oh, not gonna. That's a nipple. Yeah, Java's Android. Yeah. It's so chill. I love Java because it's just like, it's so sensical. It's very logical. It's just straight and to the point, you know? Like, what more do you need, really? X over Y plus Z. Okay, we can do this. Okay, so if we do this with respect to X, we'll get 1 over Y plus Z. If we do this with respect to Y, we're gonna get 1 over Y squared. Would it be negative? Yes. Negative 1 over Y squared times X. And then negative 1 over Z squared times X. (813). So Y plus C is 1 over 4. Negative 8, I think. And then negative 8/9. Strange numbers. But, and then this is the same thing, so I'm not gonna belabor doing this. We'll get there. I'm probably gonna, I might wrap up soonish. I know it's like a hella short stream, but like, actually, you know what? We can do the rest of these problems. The React Native stuff makes iPad dev super easy with JavaScript knowledge anyway. That's so cool. Maybe it's just come like farther. I don't know. There was, last time I looked at it, it was just all like licensed BS and like a bunch of other stuff that you needed to do. Whereas like I used to be able to do App Inventor and then I could just load APKs onto my phone. Does this stream have a Discord? I do have a Discord. Discord. There you go. That's actually the most useful command that I have. Am I doing 31? Okay. Ooh, wait, I see word problems. I see word problems. Okay. The temperature T in a metal ball is inversely proportional to the distance from the center of the ball, which we take to be the origin. The temperature at the point 112 is 120. Find the rate of change in the direction toward the point. Okay, so... Okay. We have a function t of x, y, z that equals something. And at 1, 2, 2, it equals 120. So... Okay, we need to go to the point. Our v is going to equal 2, 1, 3, because they gave us that. Which means our u is going to equal... I don't know, what is that? 4, 1, 9, square root of 15? No. 14. No. Yes. 2, 1, 3. Cool. Okay, so a gradient vector, we would normally be taking the... We'd normally be taking the... Okay, let's rewrite this as -1/2 for my sanity. -1/2. There we go. Okay, so with respect... Okay, for any of these, we're going to have -1/2, you know, x squared plus y squared plus z squared to the -3/2. That's our, like, preemptive thing, right? And then we have 2x, 2y, 2z. Cool. Which we can then plug 2, 1. Nope. 1, 2, 2 into. Which will be, oh god, okay. So -1/2. 1 plus 4 plus 4 is 9. What's 9 to the 3/2? Please be a nice number. 27. Okay. Which is -1/2. Oh, 1/27. 1/27! Hey! Thank you! And then we have 2, 4, 4. That is 40 plus 14, which is 54. -1/54. Okay, I lied. This can just be -1/27, and we can change this to 1, 2, 2. Yippee! Oh, I could have just divided that 2 out. Okay. We got 1 over thing. We have thing. We gotta dot it. Delta F. Dot U. Equals. Negative 1/27th. Oh god, this is gonna be so messy. It's okay. Negative 1/27/14. That's not that number, but we're gonna forget that. 2 plus 2 plus 6. Living the good life. Living the good life here. That's 10. That is beautiful. Is it right? Man, that's happening an annoying amount this stream. Sorry about that. I'm gonna do that one. Wait, did I say this was 31? Yeah, this was 31. I'm gonna do the second one because this is the same thing that I was doing before that I didn't finish. Let's see. What's the last couple things here? 49 and 60. Cool. All right, okay. Oh, I got a sketch. Ooh, we gotta sketch something. That's fun. Okay, so fxy. What's xy? Find the gradient vector at that. Cool. We'll do that first. Really easy. And that's at, they're asking for 3, 2. So that will be 2, 3. And use it to find the tangent line to the level curve fxy equals 6 at the point. Okay. So sketch the level curve, the tangent line, and the gradient vector. So xy, what does xy look like? What does xy look like? Well, I don't know off the top of my head what that looks like. Riemann zeta function is insane. Oh wait, xy doesn't. Do I have to wait? F equals F. How do you graph this? Am I going insane? How do I graph this? I mean, I can just get points, I guess. Huh, X, Y. It is 0 along both the, yeah, so there, it is 0 here. And here. But like, if it's 1, wait, this is a 3D curve, right? Is it 3D? No, it's 1D. What? But like when x equals 1, like when x equals 1, y can be anything. Oh shit. It's like, it is 3D, isn't it? Because it's just z can be anything. So like when x is 1, y is like, when x is 1, y is here. How do you draw this though? What? What the hell? Okay, okay, okay. Y is linear. Wait, okay, so if x equals... If we say x equals 1, right? So let's say that this is x and this is y. I think that's usually wrong, right? Don't we normally say x and y? We'll do that. So if x equals 1, y is going to equal a line like this. So that's that like space there, and then it's going to go up. So it's a plane that infinitely extends. No? Y is linear? Wait. Wait. Whoa. Like, okay, let me put points in. So is it z equals xy? Is that what that is? Let me... This is what's definitely gonna get me on the midterm. Oh, equals y. Oh. Okay, yeah, it looks weird as hell. Sorry, I graphed it. What the heck? How does this exist? Oh my god, what is this? What the heck is this? Is it, maybe it's not, wait, what if I just say XY? Oh, it's a different thing. Oh. This is so weird. What the heck? Okay, so, yeah, okay. So x equals 1. Yeah. F of this equals y, which is a line. Which is like... What? Like this? Kind of? But they keep getting like steeper then. So like here, and here, and here? Oh my god, this is breaking my brain. Let's see. Let's see what problem. Wait, did I have to do problem 60? Oh my god, why? That's really weird. We're gonna definitely come back to that and not just skip it so I don't have to do it on stream. Nope, definitely not. Just plot points. Actually, you're so real for that. Let's do that. Okay, so x equals 1. Y equals 1. Screams and falls on the ground and cries. My mic is banishing me to the realm of fucking shadows or something. So it goes like this. And then if like x equals, so when x equals 0, it's here, and y equals 0, it's here. What if x equals 2 and y equals 1? Then that's 2. So if x equals 2 and y equals 1, then that's here. And x equals 3, then it's here. Is it not helping that much? Wait, but that's the only ones that it can be, right? What about if like x equals... No, what if x equals 2 and y equals 4? X equals 2 and y equals... Oh, that's too high. I can't do that. Fine, x equals 2 and y equals 2. Here, that'd be 4. 1, 2, 3, 4. What the hell is this thing? What the hell is this thing? It's like an explosion. I don't know, maybe a parabola. I don't fucking... bro, I don't know. Just a big sad face. Just a big crying sad face. That's what I think this graph is. If I really think about it, Chad, I think this graph is sad. Mathematicians when they can't... Engineers when they can't use 3 for pi. Oh my goodness. Okay, fine. Yeah, I'm gonna do 60. I lied. We're fucking skipping this shit, dude. Okay, at what point does the normal line intersect the sphere? Okay, cool. So for an ellipsoid, 4x squared plus y squared plus... Hi, Rev! Oh my gosh, what's up, dude? I'm gonna end stream kind of soon, I think. My brain hurts. My brain hurts. Well, not really. I need a gradient vector. Oh, I need a gradient vector, please. 2y, 8z. That's a gradient. That is the normal to the... It's okay, the wind has been our very dear friend this stream. I'm a math major, lol, don't creep us math, kids are not hated it is. Yeah, I'm kidding. No, I love math. It's just sometimes, honestly, the best thing you can do, like, I will say, I like the math majors I know, I feel like a lot of people kind of just like push through stuff, but as an engineer, the most important thing I can do is to literally just close my eyes and say this problem doesn't exist for the next hour. And then I come back to it and I open my eyes and somehow I'm magically better at math again. That's like the best advice I got. Sometimes you just get really in your own head about something and then you go and you do something else and you eat some food and you come back and you're like, oh, that actually wasn't that hard. I don't know why I didn't see this one thing. Obviously, you can't do that during a test. Lactic math acid. That's so true. That's so true. That's so real. Okay, how do I turn this gradient into... oh, through something. Never mind. It's asking for a point. 1, 2, 1. So that will be 8, 4, 8. Okay, so this is the normal line we have. It's not a line yet, but we can write it as a line because this is a direction, and we have a point, so we can write it like 1, 2, 1 plus v, or I don't know, t? Yeah, plus t, 8, 4, 8. If we want to write it as a vector way. We could probably write it as a parametric way too if I think about it for 3 seconds, but I just want to write it as a vector because I don't have to think about it then. And then it's asking where does it intersect with a sphere. So in that case, I might need to write this as a line that's not in vector form. Yeah. How do I do that? I can do a symmetric equation, I think. How do I write symmetric equations for these? Symmetric equation for a line. It's in my search history already. Duh. Oh, is that an ellipsoid? Yeah, it's a sphere. So x minus 2, 1 over 8 equals y minus 4 over, no, y minus 2 over 4 equals z minus 1 over 8. Teehee. You can't see that. There you go. Okay. And then we have to solve this with the system of things. Sometimes you just need some little things. X squared plus y squared plus z squared equals 102. So, I don't know, what's the first thing I can do? I multiply all this shit by 8. Times 8, baby. X minus 1 equals 2y minus 4 equals z minus 1. Thanks, yeah, have a great day, Luigi. So now we do this one. X minus 1 equals z minus 1. X equals z. And then x minus 1 equals 2y minus 4. X equals 2y minus 3. I didn't mean to do that, actually. I don't care about that. I want everything in terms of z, so we'll just kill y. That's from my math professor. He says kill so much that it's just implanted in my brain. This is z plus 3 over 2. I think. That looks like a 2. There we go. Is that right? 4 over, yeah. Dope. So now we just do this. Z squared, so 2z squared plus z plus 3 squared over 4 equals 102. Look at that. Look at that beautiful, beautiful problem. Multiply everything by 4, because why the hell not? And then I'll multiply this out. Z squared plus 6z plus 9 equals 102, baby. Not 102, I multiplied it by 4. What's 102 times 4? 408. That's a big number. And then we just gotta do a little quadratic. We gotta do a little quadratic formula, but I don't want to do that right now. What's 408 minus 9? 399. There's like a song about that. No, there isn't. Maybe there is. What's that one Christmas song? Yeah, you know the one. I won't elaborate. 399 can be divided by 3. All these things can be divided by 3. We're so scuffed. You know what? You know what? Yeah. My computer and my yeah, okay. It's okay. My computer just hates me. There's like a ghost living in my computer or something. You know how it is. There we go. Alright, anyway, I think that's a perfect, wonderful place for us to stop, because the ghost also froze my body. Yeah, he's killing me right now. So I have to go get raptured, I guess. Classic Wednesday moment. Oh. Ghosts. You know how they be. You know how they are. I will see you guys, when will I see you guys? That's a good question. Maybe Saturday? Dude, my stream schedule is so... I wish I could stream 3 times a week, like I could normally. But now I'm like, I can't do that as much. See you next month. No, I'll be here on Saturday. I'll be here on Saturday, I swear. Yeah, it's been like all over the place. If you looking to get notifications when I do stuff, the best way is to be in the Discord. Awesome, I love that didn't even work. Or on Twitter, but I keep forgetting to post to Twitter. So, yeah, the best one is definitely the Discord. Okay, I will see you guys later. Sorry for the shorter streams, but I've been busy with stuff, sadly, that I can't really do on stream. But we did this on stream, so that's pretty cool. That's pretty awesome. All right, I hope you guys have a great day. I really don't know how this looks on the VOD. It's me creepily being here. Okay, goodbye everybody, have a lovely day.